are going to carry along with you over the next few years. They're included in SATs and ACTs, probably a little bit more likely on the ACT than the SAT, but you will see them. And again, you're going to see them in your the remaining math classes that you take here. So I strongly recommend that you get really comfortable working with these. Okay, so the first, we're going to talk about two special triangles here. The first one is a 45, 45, 90 triangle. The 45s refer to angle measures. So we have 45 degrees, and 90 degrees. And if you recall, in a triangle, sides opposite equal angles are equal. So since these two angles are 45, the sides opposite them are equal, giving us an isosceles right triangle. And so you may hear me refer to this as an isosceles right triangle as well. So 45, 45, 90 isosceles right mean the same thing. Okay, and let's take a look at these patterns. Okay, so since you know the legs are equal to each other, I'm going to call each one of them x. And I can solve for the hypotenuse here using Pythagorean theorem by saying the sum of the squares of the two legs. So x squared plus x squared is equal to, I'll call the hypotenuse c. So c squared. So this is Pythagorean theorem. And if I combine my terms, I add the x squareds together, giving me 2x squared. I can now extract my square root. When I extract the square root, I get root 2 times x is equal to c. And so I'm just going to rewrite this a little bit, move my x in front. And so this right here is the special pattern for a 45, 45, 90 triangle. Okay, so when you're trying to identify information about this, as long as you know one of these things, you can find all the remaining values for these sides by fitting them into this pattern. Okay, so x, and x root 2 is the length of the hypotenuse. Okay, now, before I move on, there is one concept I am going to review on each of the topics that we go through here, and that is that if you divide by a square root of a number, that's equivalent to multiplying by the value you would use to rationalize this denominator, which is going to be divide by n multiply by root n. Those are equivalent values. Okay? So dividing by a square root, in this case, is equivalent to dividing by 2 and multiplying by root 2. Okay? So again, we'll review this in each of the few slides that we talk through. Okay, so let's take a look at the 45, 45, 90 pattern. Okay, so you can see there's lots of different pieces that we're going to test here. Okay, if you're trying to write all this stuff by hand, I would definitely encourage not to. If you are planning on it, I would screenshot this and write on Notability, or if you have the notes opened up, that would be ideal. Okay, so let's take a look at our pattern for a 45, 45, 90. Again, is x root 2. Okay, and so the easiest one to find is if you're given one of your side lengths. Okay, so if you know what your side length is, you can find the remaining pieces by just plugging that in for your x's. Okay, so if one side is 2, then that means the other leg is also 2, and the hypotenuse, you plug it right into this form, 2 root 2. Okay, so you can find these by just plugging directly into your patterns. Okay, so I want you to try these remaining 4 triangles and see if you can identify the unknown pieces, A, B, or C, based on the given piece by plugging directly into this pattern of x root 2 and for the 45, 45, 90 triangle. All right, so let's take a look at these patterns here. Okay, so if your given leg is 3, that means the other leg is also 3, and the hypotenuse is 3 root 2. Again, just plugging it directly into that pattern. Now, even if the leg isn't just an integer, you can still use the same rule. Okay, so we're given a radical for our leg. That means the other leg is the same measure, 4 root 2, and the hypotenuse is going to be 4 root 2 times root 2. Okay, so root 2 times root 2 is 2. Okay, it's square root of 4, which is 2. 2 times 4 gives you 8. Okay, same in the next example. 3 root 2 is one leg. The other leg's going to be identical. So 3 root 2, and the hypotenuse is that measure times root 2. So root 2 times root 2 is 2. 2 times 3 is 6. And then this final example has a radical where the radical is not going to cancel out. You have 2 root 3. The other leg is going to be the same measure, 2 root 3. And if you took 2 root 3 times root 2, you get 2 root 3 times 2, which is 6. And that's going to be your remaining measure. Okay? So all of these are based solely on this pattern of x root 2. Okay? These next two problems are also based on that same pattern. This time, though, you're given the hypotenuse, but it's in the form of x root 2. And if your hypotenuse is given in that form, the way that you find the length of each leg is you just take the number that's in front of the root 2. So this fits the pattern x root 2, where 4 is x, so that means that each of your legs is going to be 4. Okay? So for the other one, again, same idea, x root 2, where x is 15, and so you can plug that directly in for your lengths. All right, the challenge comes when you're looking, or when you're being given the hypotenuse. Okay, so let's say they gave you, or you're given the hypotenuse of this isosceles right triangle. If that's the case, then we use the idea that if the hypotenuse is equal to x root 2, you can solve for x by just dividing your hypotenuse by root 2, and that's going to give you the value of x. But remember, dividing by root 2 is equivalent to dividing by 2 and multiplying by root 2. Okay, so that's the steps for rationalizing a denominator. So really we can use that as a shortcut because this leg is going to be the hypotenuse divided by 2 times root 2. The hypotenuse divided by 2 times root 2. That's going to give you the length of each leg. Okay, so if we were given the hypotenuse here, we can find the length of the leg by taking 16 divided by 2, multiply by root 2. Once we do that one time, then we know the other leg is the same thing, 8 root 2. Again, we're finding what x is for these specific triangles. Okay, I want you to see if you can answer the remaining questions here. This bottom row of 4, when you're given the hypotenuse, can you find what the corresponding legs would be for these isosceles right triangles? Right, again, being able to work with these patterns makes it much easier and quicker to manage these types of problems. So definitely when you're working through this, if you're given the hypotenuse, divide that by 2 and multiply by root 2 to get the length of each leg. So 20 divided by 2 is 10 times root 2 gives you your measures. Even if it's not an even number, we can still do the same thing. Take your hypotenuse, divide by 2, multiply by root 2. So here we get 9 over 2 root 2 as our legs. Same with 15, divide by 2, multiply by root 2. That gives you the length of your leg. So 15 divided by 2 times root 2 is our answer for those. And now, when we come to this last question, this last question kind of returns back to this first form. And the reason for that is when we divided by 2 on this one, we don't need to rationalize. Okay, so if we want to find what the length of each of these x's is, we can simply take our 5 root 6 and divide by root 2, and that's going to give us our x value. And so here, the 2 and the 3 inside those inside the radicals can cancel out, leaving 5 root 3 as our x value, and both of these are going to be the same because it's an isosceles right triangle. Okay.